Okay, I'll sing. Yeah. So hi everybody. I'm very happy to welcome you. My name is Isabel. I'm the co-founder of Translated, the mother company where you stand. I'm very happy. Today is a very exciting day because it's the pitch day from PySchool. PySchool is a spin-off of Translated, let's say PyCampus. And we're going to present, the students are going to present the sponsors, what they've done for 8 weeks. So it's a very nice event. We're all excited. They've prepared very hard for you today to judge the work they've done. And I want to welcome you here. Seb is going to present the session today, and we're lucky for the weather, so I hope you're going to have a very good time. I'm saying hello to all the participants online. I think there are more than 60 people, so welcome and thank you for following us. Thank you.
Thanks, Isa. So this is a ritual by now. We've done it 12 times already. Many of you will know several of the things that I'm going to tell, but there are a couple of news as well. So let me go through them. That's the stuff that most of you know. PyCampus, where you are, is an investment fund at seed level. We do investments mostly in applied AI companies, seed investments, small investments on teams that show traction. These days we do most of our investments with Y Combinator in the US, and they end up being very good investments. Several of the startups that we invest in then spend some time within PyCampus physically, so the location here is a bit of everything. It's PyCampus because startups are here. It's Translated because our offices at Translated are next door and in other villas around the neighborhood as well. And it is, well, PySchool because we have our offices here as well. So a bit of everything. I'll give you news from PyCampus. The latest investments. Interesting to know, to hear about. This is so new that I can't actually tell you all the details. It's going to be public, I think, next week. So PyCampus is doing an investment in a company that is applying large language models, ChatGPT and GPT-like, to CRM problems, to customer relationship management problems. And they do very exciting stuff with technology. Another recent investment is Giulia, a language school, together with Treccani, the encyclopedia publisher. So this has some technology elements, but mostly it's about the human component at the heart of Translated's activity. So Translated, as many of you know, has two, I would say, legs, two souls, humans, machines, much like PySchool, where we make sure we work on the interface between people and machines. At Translated, one of the important logos that we have at Translated is we believe in humans, and so this language school is about this, and it has this special twist due to Treccani's presence. Wiraki is another recent investment. The basic idea at Wiraki is to optimize recruitment thanks to peer referral. So it's students referring other students and giving, rankings or pointers towards the best among them. And they've built a platform. Wiraki has built a platform which functions much like a recruitment platform, but where the ones to benefit are the people who do the referral. So it's a very original model in recruitment that we haven't seen before. Okay, and I'm going to say a few words about how the Pi School of AI program works, for those of you who need to know the mechanics before we show examples of what we've done over 8 weeks. So the pain that Pi School of AI solves is the following. We help companies that need to prototype AI projects and that don't know, that have no experience in doing so. Issues that we know they encounter are access to talent and lack of experience in running prototyping projects, which, as you can imagine, looks like software prototyping, and there's a ton of methodologies for software prototyping, Agile, Scrum, you have it. It looks like it, but it's also very different because AI projects have a much larger uncertainty, a much larger technological risk in making estimates, for instance. So while in Scrum methods, it's important that teams can make estimates about the cost in points or in person days of certain features to implement. Well, in AI, this is extremely difficult to do because a lot of what we do is experimental, is based on state-of-the-art algorithms. The state-of-the-art moves, changes week after week. And therefore, the prediction of how much effort implementing a certain feature is going to cost, well, this prediction is very difficult, much more difficult to do than in traditional software engineering, which itself is much more difficult than, say, in the building industry to take, or in manufacturing, to take examples where variance in estimates are relatively low by today. And so we've adapted our methodology to these cases. And we've implemented it over a number of projects. So the way it works is we start with determined business pain. We usually take some data from our sponsors, which then become stakeholders to the challenge. We start, on the other hand, from the existing state of the art in AI. So that means usually we go and look at the scientific literature, recent scientific literature, recently released products or libraries. We work on these things during 8 weeks at time box. So we know when we start and we know when we finish. This inspiration is literally from agile methods, but it's also the kind of thinking that pervades how startups work, where every day you burn cash and you'd rather, finish an iteration because then you will need to decide whether to continue, to pivot, or to stop the effort. And so this is the exact same thinking that we have, put into the design of the program here. At the end, the sponsoring company takes over the intellectual property of the prototype we've built, and then they integrate it and turn it into a product or a service. The ingredients to that, the sponsor I mentioned already. Fellows are the people who are going to present the projects they've worked on tonight. They're usually students or young professionals, people with often enough some academic or some project experience in AI who want to acquire the extra box, the extra paragraph on their CV, which is applying that knowledge to a real industry problem using state-of-the-art techniques. And then Pi School, from its extensive network, recruits, finds mentors, and provides coaching in terms both of science and method to these teams to be able to implement these challenges in 8 weeks and make sure it's not chaos, but it's actually orderly and does deliver something. We've done this 92 times, so the last project that you'll see, that you'll hear of tonight will be the 92nd project that we've done at Pi School ever since 2017. 188 alumni have gone through the, through the experience. Session 13 will be in June, July. Here are a couple of companies that have trusted us and that we've worked with over the years. And I would say, without further ado, let's hear from the first project tonight. The next slide is this one. Okay.
So, hi everyone, my name is Gianfranco Romani, and I'm going to present the challenge sponsored by Translated, which is about machine translation. As you all know, translation can be done in several ways. One of which, the classic way, is by hiring human translators. These professionals can achieve high quality in translation, but they're also very expensive. And also it's time-consuming to translate a lot of documents or very long texts. So on the other end, we can use automatic tools to perform translations. These methods are quicker, they are cheaper, but they're not as accurate as when we are hiring human translators, especially if we care about consistency constraints for style, domain, or terminology. Our sponsor, Translated, which is a big player in the field, developed an approach called ModernMT that solves all these problems. This approach, which is a mixed approach, is based on a neural network that I think you all know, Transformers, which was designed by Lucas Kaiser, a PySchool mentor and also a researcher for OpenAI. On top of this model, they're using human to further improve the translation and bring them to the next level, as a professional translator will do. But this approach is from 2017 and Translated as an innovative company that is always seeking for state-of-the-art approaches. And so we are looking at new models that are updated, which are the large language models. You all know about Llama, Bloom, and so on. These models are really good in general purpose tasks, in natural language general tasks, but also they are really good in specific tasks, like translation. I think you know ChatGPT at this point, if you're here, and we can use ChatGPT, for example, to perform translation. To do so, we are using an instruction called prompt, which is, in this example, is very simple. So we are just telling the model that you want to translate from English to Italian. The translations are quite good, but this is not enough for us. We can improve the results of the translation of these models by improving the prompts. So we have to be smart about how we design the prompts. The first idea we had was to use examples in the prompts. So we are adding high-quality translations as examples. In this way, the model can have a comparison, can use this high-quality translation to perform high-quality translations. But we can even improve this approach. We got inspired by the paper published last month by our mentor, Yasmin, and the key idea of this paper is to be smarter about the examples we are using. So if we start from a pool of examples of sentences that are taken from several domains, we can use sentence transformers, so a deep learning model, to retrieve the sentences that are closer for meaning and domain to the one we want to translate. In this way, the model can learn even more how to follow the constraints for consistency, style, and domain, and terminology, and so on. And the performances are much better. So we designed a pipeline for all these approaches. The pipeline we are proposing is model agnostic. That means that it does not depend on the model. So if one day, maybe 1 month from now or 1 year away from now, a company releases a new model which is way better than the one we are using, we can still use the pipeline we designed and developed. In this way, we can use all the prompting techniques we design, and the performances are going to be better. During these 8 weeks, we tested the pipeline on 2 models, GPT-3 and GPT-3.5. As you can see, the performances are improving. So we started from GPT-3, then we have GPT-3.5 with random example, and then the second idea, so using FATSI matches, which are the examples similar to the sentence you want to translate, And for all the metrics we have used, the results are improving. Our approach is just not good. It is also cheap. So if we are translating 1,000 words, which are more or less 50 sentences, our pipeline will cost 200 times less compared to a translation performed by just humans. And you can imagine this a scale. So if we are translating not just 50 sentences, but a lot of documents, the difference is really important. So we think that translated with ModernMT can use large language models to improve translations and help even more translators in their work. And so in that way, break down the language barriers that are still present in our world. The team that work on this challenge is composed by Madi, Marco, and me, Gianfranco. Unlike large language models, where, as I showed you before, similarity was the key to improve performances, in our case was diversity. Diversity was the strength that led to the success in this challenge. I would also like to thank our mentor, Yasmin, that helped us a lot to use techniques that were proposed 1 month ago, that are state-of-the-art and welcome this and use these models. Our coach, Francesco, and the stakeholder, Davide. Thank you for your attention.
Thanks, Gianfranco. And I think I want to hand it over to Davide for a comment on this challenge.
Thank you. Hello, everyone. I'm Davide, as you've seen in the stakeholder of this project. I'm the Director of AI Engineering here at Translated, and I mainly work at ModernMT, our machine translation technology. So I just want to take 1 minute of your time just to give you the right, I would like to give you the right context and of what we are now, what is happening, and why this is so important for our industry. To me, it's rare to be able to witness an epochal change in your field. And this already happened twice in my career. So machine translation started with rule-based system, where you literally have to specify how to transform one word to the other. It was a very long time ago. Probably I was still studying in my high school or something like that. Then statistical engines came, and where basically they started to understand that it's not about rules, but just observing the data is the key part. And but no neural machine translation at all. They're just custom models created, even language models created to try to put the statistics under the service of machine translation. And then happens 5, 6 years ago about that everything changes. Neural machine translation came to the world, and in just few minutes, anything before that technology was like light years behind. It was not even, it was really amazing to witness something like that. And with ModernMT, we had built our solution with statistical machine, of course, machine translation, and then we rapidly tried to implement everything back to neural machine translation. That was huge, and this is, to me, seems like the next big thing about natural language processing and AI, I would say AI in general. So this is going to be something that probably you will tell your children. Yeah, I was there when that happened. So this is really amazing. We are in Translated. We are working into trying to bring this power to our translators. So we want to create products that are meant to support them, make them more efficient, and be smarter and smarter, way smarter than machine translation right now, for example. So this is what we are working under the hood. And one very last note is about yesterday we released a huge, I would say a huge thing for ModernMT, because we are covered for the first time in the language industry 200 languages at in a business solution. So it means that we can currently serve 200 languages with our real-time adaptive machine translation. And all our translators from all around the world can start using right now. So thank you all for this time.
Thank you, Davide. And by the way, nice to meet you all. My name is Francesco. As Gianfranco said, I'm the coach. I was the coach for this challenge. And so first of all, allow me to thank again the team composed by Gianfranco, Marco, and Madi for working on this awesome challenge. Just like Gianfranco mentioned, I think the greatest strength about this team was the diversity, right? And the ability to bring together different skills and complementary skills, if you will, that eventually led to a successful outcome for this challenge. I also want to mention that this team was really good in kind of not getting carried away by excitement and things like that about new technologies and new models and stuff. They did not neglect engineering work, as you observed, which allowed them to prepare like an infrastructure to run quickly experiments, iterate over them, and try different things in as little time as possible, which in our case is just 8 weeks. I don't want to repeat what Davide just said, but just to conclude, large language models really took the machine and deep learning world by storm. You saw that even fields where you thought that technology was somehow consolidated are kind of questioned by now, because these technologies are so disruptive that you just cannot ignore them. And so I'm really excited to see what we can achieve in the coming years, also for machine translation using large language models. So thank you again, and I'll hand it over to Neeraj for the next presentation.
Thanks, Francesco. Hi, everyone. I'm Neeraj, and I'm here to present our challenge on the behalf of my team. So starting with chatbots. Yeah. So why chatbots? Because chatbot economy works. Why? Because chatbots replace the incoming call activity that are being processed by human beings with automated chatbots. So yeah, simple automation works. But now, we see that the benchmarking of chatbots is really important. Because if your chatbots are not efficient and you're not able to evaluate them well, the queries of the customers will reach your customer agents, and it will cost time and money. So a lot of people spend countless number of hours benchmarking the chatbots or evaluating the chatbots, and even after making a very small change to the chatbot infrastructure, they have to spend a lot of time in manual testing before deploying them. But with the advent of LLMs or large language models, we have seen that LLMs can really perform as well as humans in variety of tasks. So what if we could replace this manual testing step with LLMs? So in this way, the process of deploying chatbots will not only become efficient, but it will become cheaper as well. But how do we do it? So we take the business context that we have and pass it to LLM or ChatGPT, for example. Now this LLM will generate some fake data or try to impersonate some customer and send these questions to the chatbot. And it will keep having the conversation with the chatbot until it realizes that the chatbot is able to answer its question or not. And eventually, it will take the entire document the dialogue flow, and share it with another large language model. So this LLM will go through the dialog flow and evaluate that how much efficient this chatbot was. So you see, in this way, we really were able to replace an entire manual testing step before for the benchmarking or evaluation of a chatbot. Let's have a look at how we do it. So I'll take you through a very quick demo. So as you can see that in this chatbot, on the right hand side, we have our application, and on the left window, we see McDonald's job hiring platform. Yeah. So what happens is that on the right hand side in our application, we provide the application with some sort of contexts or some sort of prompts from which the LLM could generate some sort of questions and ask the chatbots, like here in the right, like here in the left. And it will keep on having the conversation with the deployed chatbot, and finally, it will decide that was the chatbot really able to answer the question or not. So as you can see, it has finished the evaluation, and it is the published result, task failed. Why? Because chatbot says that you should ask this question in the interview. So it essentially does not have the answer. Okay. And this evaluation process is, as I mentioned, it is very efficient as well as it is very cheap. Let's do some math. Oh yeah. So let's say we have 50 conditions on which we want to test our chatbot. And each condition has 10 variations. Let's say there are 10 ways of asking that condition to the chatbot. And for each variation, it takes 5 human minutes to ask those questions and get the answer and decide. And it takes 20 euros to employ a human being to perform the same task. So one session of benchmarking costs 833 euros to an organization, which is a lot. I'll quickly take you through the tech stack as well. So we utilize a wide variety of technologies ranging from Selenium to ChatGPT API to Streamlit to create this beautiful user interface for our application. So we essentially use Selenium because the chatbot we used was deployed on a web application, and we automated these interactions with the help of Selenium. Now, there can be a wide variety of chatbots that are not only deployed on web, but on mobile as well. So one way to extend this project would be that we could find out ways to automate the interactions with the chatbots that are deployed on mobile. And this solution will not only help you to make sure that your chatbot is efficient, it will also help you to compare different chatbot vendors when you're going to buy a new one for your organization. So you perform the same tests with this solution, comparing different chatbots, and find out which one works best for you. And the market for this business is ever growing because chatbots are required in financial services, retail, traveling, automobile, and whatnot. Finally, the team. This project was developed by Shubhanshu, Adarsh, and me, and we were coached by Vij and Cristiano. So yeah, thank you so much.
Hi to everybody. I'm Cristiano, lead AI coach. I was supervising this challenge, so thank you again, Niraj. I want to spend some words more. So even before we realized that we are witnessing, other people said that we are witnessing a new era where really there is a new revolution going on. Especially what it's really interesting about this new era is that really the revolution is about machine and human interaction and also machine-machine interaction. So in this challenge, the fellows were able to use a large language model, think about ChatGPT, to benchmark, to test another machine that was, in this case, chatbot by some companies like McDonald's, Nestle. And this is really, really interesting. So we were using a large language model acting as a as a human being to test another machine. So we are in this really, really interesting era. So it was really, really exciting working on this challenge because it was super state of the art. I remember that during these 8 weeks we were looking at Twitter, discovering some new papers, some new libraries, tools, and chatting together on our Slack channel about the team, looking to try this new solution almost daily based. So the team was very, very good in learning so fast things that came out just 1 or 2 days before. They also, in particular, in the last weeks, very, very smart in using machine learning techniques together with web development techniques to interact with chatbot. So really amazing. I'm really proud of Neeraj that I met also in person. I'm very happy. But also the Shubhanshu and Adarsh that are following us online. So congratulations again. And if everybody has later some question, more technical one, feel free to ask during the networking event. Okay? So I will leave the floor to the next one.
Hi, can you guys hear me? Okay, great. So yeah, hi, my name is Johanna, and I'll be presenting the results of the Explainable AI for Wildfire Forecasting Challenge. The challenge was sponsored by the National Observatory of Athens. They are currently working on a project called Ceasefire. Yeah, you guys probably can't read it, but it says Earth System Deep Learning for Seasonal Fire Forecasting in Europe, which is sponsored by the European Space Agency. And our project was, part of this effort, so to say. So yeah, the picture on the right-hand side might look like it's from an apocalyptic movie, but it is actually from the 2021 wildfire season in Greece. And yeah, you can see wildfires are quite scary, but the problem is actually a lot larger. So the big problem of wildfires and climate change is that they are kind of a self-reinforcing vicious circle. So on the one hand, wildfires kind of actively contribute to climate change. So globally speaking, they're responsible for approximately 10% of all carbon emissions. And this kind of already leads us to the second problem, that global warming is leading to a lot drier conditions in a lot of regions worldwide. And these conditions lead to unpredictable wildfire behavior, and especially to a lot of unusually large wildfires, and then kind of rinse and repeat, and the circle starts again. Yeah, so as you can see, there's really a large incentive for developing models that can successfully predict wildfires. So for example, so that you can be able to evacuate people in time, or to make informed decisions about where to station firefighters, for example. And there is actually a lot of research going on in wildfire prediction. So there's two large groups of models. On the one hand, there's physical models and also machine learning. So physical models tend to produce pretty good results, but there's a lot of domain knowledge required. So you need to explicitly model the physical and environmental conditions that lead to wildfires. And they also tend to be very compute intensive. Machine learning models, on the other hand, are relatively lightweight. And another advantage of them is that they are data-driven and descriptive rather than prescriptive, so they can learn from the data the conditions that led to wildfire. And this is especially important because climate change is kind of changing a lot of the notions that we had about which processes cause wildfires. However, there is a drawback that machine learning models tend to be quite complex black box models, and we do not know why they make their predictions in the way they do. But we still see that machine learning is kind of the way to go. And our sponsors from the National Observatory of Athens are like really quite pioneering the way for predicting wildfires with deep learning. And this is also why we decided to reuse some of their work. They developed some really good models and that can successfully predict wildfires. And we then started to employ some explainable AI methods on those models. And for those of you that ask themselves, what does explainable AI do? So the answer is, well, it's quite complicated, but to put it simple, it's kind of finding explanations as to why a model makes its decision in the way it does. So there's actually a lot of research going on in explainable AI, but it is mostly done for classification cases. So, for example, if you have a picture and you want to determine what is in the picture, you could say, okay, this is a cat, and the reason why it is a cat is that it has a tail and pointy ears and a fuzzy coat or whatever. But our use case is a little bit different. It's called segmentation. So we don't want to predict what is in the picture. So we want to see where the thing is in the picture. So in this example here, it's like, where is the cat? But for us, it would be, where will the wildfires happen? Okay, so how can these explanations look like? And for that, I brought one example. They're called Shapley values. It doesn't matter too much what they are, but they are pretty much a rating of how much each input feature contributed to a prediction. And in this plot here on the x-axis, you can see the feature values for total precipitation. So the further on the left, the lower the value. And on the y-axis, you can see how these values contributed to a wildfire prediction. And as you can see, low precipitation, so like dry conditions, kind of increase the prediction towards fire. And then like very humid conditions have the exact opposite effect. So when it rains a lot, the risk for wildfires go down. So how did we get to these findings? So we started out by exploring the data set that we got from our sponsor. So it is a quite complex data set that has a lot of data on features that could potentially influence wildfire behavior, so precipitation, temperature, surface pressure, and so on. And also the burned area in each region worldwide. Next, what we did is explore a little bit in what different algorithms and Python packages and everything were available. And we soon found out that there's not a lot of explainable AI for semantic segmentation. So as I said, we try to find kind of where a wildfire will happen. So for each pixel, we have a prediction that's will burn or not. So there will also be explanations for each pixel. So we thought it would be a good idea to aggregate the explanations, but this turned out to be a little bit complicated. So we thought maybe what we're doing is the wrong thing. So for a little while, we switched from merely predicting whether there would be a wildfire to predicting the size of the wildfire that would happen. And the results of how well or not well it could predict were actually quite good, but we still had the problem that aggregating the explanations proved kind of difficult. So we decided to kind of go back to the roots and do explanations for smaller regions. And what we ended up doing is developing a dashboard for visualization for those explanations. And so this is what it looks like. Maybe I have to step over a little bit. So here is, maybe not. So here you can see the dashboard. There's a region in Eastern Europe. You can see where wildfires are happening. And then you can you still hear me? Yeah. You can choose the explanation algorithm you want and the window size you want. And yeah, it's kind of interactive and customizable. And then for each of the input features, so for example, relative humidity, sea surface temperature, and so on, you can get the contributions. So obviously, this is still some sort of like work in progress, but we do hope that, there will be some more work on this project so that it can really do, maybe some good in the world. Yeah, so these are the main packages that we use, Captum and Shap. They're both Python packages. If anybody's interested in like working on explainability, it's really a hot topic right now. There's a ton of like tutorials online, but also if you have questions, feel free to approach me afterwards. Yeah, and last but not least, this is the team. So Giovanni is unfortunately not here today, but I do think he is dialed in via Zoom. And we had Cristiano as our coach and also Michele as our mentor. He is a postdoc, I believe, at the University of Valencia. And last but not least, we also want to really extend a special thank you to the research team from the National Observatory of Athens. So this is us last week, where we met at a geosciences conference, where Johannes also presented the Ceasefire project. And yeah, we really want to say thank you for their guidance and help and advice. And yeah, that's it from my side.
Thanks, Joanna. Here again, Cristiano. I want to comment a little bit. First of all, I would like to highlight that this challenge is part of PySchool AI for Good initiative, where we offer our skills, machine learning, deep learning, AI skills and knowledge to support impactful challenges for humankind. In this case, it's related to wildfire that are caused by climate change. So we feel very proud about this kind of application, you see. And in particular, we started this challenge with the collaboration with the National Observatory of Athens. And then I remember that I was, during the hiring process, I had many interviews, but soon when I met Johanna and Giovanni, a funny thing about this challenge that everybody except me is called Giovanni or similar, because we have Johanna, we have Giovanni, and we have Ioannis from Greece and another Ioannis from Greece. So it was quite funny. Everybody is calling okay, sorry? Okay. It's calling Giovanni except me. So we started working on it. It was completely new topic. So we studied the literature, we tried some, many things, failed many others, but then during the challenge, we were able to explore many techniques, and so I'm very proud about them. I'm also very proud that they met at one of the main conferences in Vienna, the NOAA team, and another thing I'm very proud of about the team is that in 2 weeks, we are invited by the NOAA team at the ESA Phi Lab in Frascati to give a presentation during the morning at an event organized by the European Space Agency, and we also will give a workshop during the afternoon. So this is a good sign that the work we have done was interesting and super useful. So thanks again to Johanna and Giovanni that I hope is online. So Giovanni, see you the 10th of May in Frascati, and congratulations again. Now it's the turn of Lorenzo. Yeah.
Hello, thank you very much for being here. My name is Lorenzo, and today I'm going to present you the last challenge. My challenge was in the field of inventory optimization, and let me start with a very small disclaimer. This was not exactly the field in which we had to develop our optimization techniques, but our sponsor decided to remain anonymous, and that's why we adapted our optimization techniques into this context. But still, it's a very interesting context. That in particular is small fair trade retail shops. Because of that, let me give you a little bit of context around it. So I would start with the definition. So fair trade is a term for an arrangement designed to help producers in developing countries achieve sustainable and equitable trade relationships. And why this is interesting? Well, it's interesting because you can see it's an emerging market here. We have this Fair Trade International, that is the organization that is given the stamp that you've seen before, right? And everyone's seen them, right? And you can see this market is increasing in the recent years. And I also want to add some numbers to that. In 2021, Italians spent 553 million euros in products containing at least one fair trade certified ingredient. That's quite a number. And 2,552 companies licensed more than 37,000 products in 2020, according to the data that we have. And we all agree that this is something we want, right? Fair trade products are something good. They want to see more on our markets, right? But the shops selling them have two main problems. The first one is the dimension, because those are very small shops, right? And they don't really have the space in order to stock all the products that they want to sell to the public. And secondly, they have a problem of management capabilities, especially if compared to the bigger supermarket chains we're used to. And on top of that, we also have that food industry sales representative still present their products in person. And we think that is an outdated way of doing business, and we want to do something about it. The question, therefore, is how can we help them? And here we come into our solution. So we're supposed to have a unified marketplace where demand meets the offer, meaning that we have all the information that we need. And in our case, this was provided by our sponsor. And our task here was to produce the heart of this optimization technique. We produced this two-step algorithm for optimization, where the first step was to build a sort of sentinel that was a sort of eye always open on your stock, and it's gonna tell you which products are doing good, which products are doing bad, right? But we didn't stop here, because we continue by producing an optimized refurbishment plan, meaning that, okay, our product is going out of stock, we need to buy it. But you can buy it at different point in times, right? To maximize, for example, the discounts that you may have on the market, right? And our optimization technique was able to leverage that. And we see it as win-win situation. Why? Because if we have more fair trade products on the market, we will have better conditions for worker, we'll have better visibility for industries on the platform, we will have an automated way to manage the stock for these shops, and last but not the least, us as customer will be able to find the products that we like on the shelves anytime. And yeah, so I will start by telling you how we solved the first problem, that is the stockout problem. And we did it by solving the problem and approaching the problem, to be honest, of overstock and stockout alert by focusing on the demand, right? Because if you want to understand when some product is about to stock out, we need to be aware of how much you're gonna sell of this product, right? In the next few days. So we approached the problem by using many different demand forecasting and time series analysis technique, from the more traditional to the state-of-the-art ones. And among those, we selected the best candidates, we fine-tuned them, and we reached some very great results. And you see our error here is decreasing on our forecasting. And but now let me go to the second point, the one we're most proud of, and that is the optimization technique itself. Right now, also with my other colleagues, you've seen how deep learning can be very useful to solve business problems, right? But here, for us, one of the biggest requirements was transparency. Because if you're a business, you don't only want to know where you have to spend your money, you also want to know why you need to spend your money there, right? And that's why we decided to use a linear program that is a method that have been studied for decades at the moment. And we know because we have some theoretical results telling us about the optimality of those, right? And on top of that, we have, therefore, transparency, reliability, but we also have scalability. Because with this optimization technique that does not require any learning, can be applied on any amount of data. So even the ones for the small shops. And therefore, it's something we really want to do. And last but not least, this method is very, very fast because we can solve this problem in polynomial time, thanks to linear programs. And in particular, let me spend some words about the optimization and the linear program itself. What we try to maximize, and you can see some calculations here on the right, was the so-called GMROI. This is a sort of all-inclusive metric. And in this metric, we see two other very important sub-metrics that you want to be very aware of. The first one is the margin. And if you have a business, you know that you want to maximize your margins over time, right? But on top of that, we want to also minimize the average stock value. Because again, we may have some bounds on the stock that we want to keep. And in general, it's always good to keep as less quantity in stock as possible. And again, if you have any question for those one of you interested here, we can have a chat about the mathematics around it. And let me conclude by mentioning the team that worked on this. Together with me, there was Francesco, who is a student at Lewis University studying economics and computer science. And he helped us giving some insights about the business. And then there was me, who I'm a graduate in mathematics and computer science, and I work on the modeling that you've seen before. And a shout out goes for the mentor, Lucas. There's an expert in time series analysis. And of course, a big thanks will go to Marcello, that is our coach. So thank you very much for your attention.
Thank you, Lorenzo. Can you hear me? Hi, everybody. My name is Marcello Politi, and I was the coach of this team of Lorenzo and Francesco Vitale in these last 8 weeks. I would like to say that I think that the fellows in this challenge have learned a really important lesson, which is how to translate a business requirement into a technical requirement and also technical constraints. Because this is something that you have always to do when you want to solve business problems by using AI. For example, it's not always obvious why the optimization, for example, of a machine learning metric could also mean a maximization in terms of profit by the sponsor. And as it always happens in real-world machine learning problems, they had to deal with really messy data, and they handle it really well. And I also think that their choice about creating this hybrid system composed of both white box and black box algorithms was really clever, because they always kept in mind the interpretability and scalability of the model itself, which is always a best practice, I would say. So this was the last speech. I would like to thank all the fellows here. I know it was really hard to work on this, but good job, guys. And I would like to invite into the stage Sebastian. Thank you.
Thanks. Thank you. So that was it for the projects, the challenges we had in session 12 of Pi School of AI. We're through with them. Before we part, I'd like to say a few words, announcements actually, of things that are upcoming at Pi School and that you might be interested in. In 2017, maybe some of you were in this very place and can remember what happened. So the place where I'm standing now is where we had Lukáš Kaiser. Lukáš is one of the inventors of the one algorithm that is powering ChatGPT and essentially most of the revolutions we're witnessing in AI these days, named the Transformer, in a paper that he published a couple of months actually before coming to PySchool to speak about it. The paper is called Attention is All Your Need and is in the Hall of Fame of Machine Learning by now. So that was in 2017. Then in 2021, Lukáš was back to speak about an upgrade or a more interesting variant of transformers for longer context, longer inputs essentially, something that nowadays powers ChatGPT when you say extremely large context windows, such as with GPT-4, 50 pages of context. And in July 2023, Lukáš is back. Now Lukáš has changed. It's not the old Lukáš who was with Google Brain. Now it's the new Lukáš who is with OpenAI. And so new Lukáš will come and speak about ChatGPT. Another piece of announcement that you might be interested in. We're organizing a workshop called LLM for Professionals for those people who would like to use large language models for their professional activity and who need to be experts at prompt engineering, fine-tuning, and few-shot learning and many other techniques that one is supposed to master when one uses large language models to accomplish practical tasks, all techniques that we put into action. You've seen examples of them in the in two of the challenges we presented earlier. And so we're going to go through 6 hours of in depth on techniques, on technology, on state of the art that people are finding out gradually ever since large language models started becoming really powerful. And we'll go into use cases and very practical work in this workshop. So this workshop has a pre-registration form on the website where you can already put down your name. I think we're still in the process of defining the exact date when we'll have, but it's certainly very soon in our calendar. And before I leave, I'm going to hand over to Isa for a few parting words.
Thank you, Seb. Thank you, everyone. So thank you for being here. We were short and sweet, just in time by 6. I want to thank everyone and say that I'm very proud of the quality of the challenges. Very proud of the quality of the fellows that came this year. Every batch we increased the quality of them. And I'm very happy for the sponsors that understand the value of PySchool to fast prototype in only 8 weeks. So we hope that these challenges were a food for thought for you to understand what AI can do for you. And if you have any questions, any ideas, please you find us and we will try to see what we can do for you. Thank you again. Bye.